All right, so here we have the notes for sections 1 and 2 for Unit 2. Just so the review preview, so we got a definition up here. Rare event rule just says if the probability of a particular observed event is extremely small, we assume that the assumption is probably not correct. So down here it says, so for example, Genetics and IVF Institute has developed a method of gender selection so that couples could increase the likelihood of having a baby girl. Suppose that 100 couples use the procedure to try to baby a girl, and the results consist of 98 girls and only 2 boys. Now, there are 2 possible explanations for these results. There's chance, just by chance you got 98 girls and 2 boys, or not chance, and the results did not occur by chance, so it appears the gender selection technique is effective. So this result is highly unlikely without anything else occurring, which means that the method of gender selection is probably pretty good if you could choose 98 girls to get that. Okay, so section 2 here just deals with the basic concepts of probability. So we have some definitions. An event is any collection of results or outcomes. A simple event is an outcome, should be of an event that cannot be further broken down into simpler components. And a sample space is all the possible simple events that occur. So all possible outcomes that you could get. All right, so example 1 here. Just says in the following display, we use B to note a baby boy and G to note a baby girl. So with 1 birth, the result of 1 female is a simple event because it cannot be broken down any farther. With 3 births, even the event of, should be event, 2 girls and 1 boy is not a simple event. These can be broken down into simpler events. So 2 girls and 1 boy is not a simple event because there's 3 ways in which it can occur. Having 1 girl, there's only 1 way that can happen with 1 birth. With 3 births, there's multiple ways this could happen. If you only have 1 kid, there's only 1 way to get 1 girl. But if you have 3 kids, this is not enough to know if the boy is the oldest, the youngest, or the middle child. So that's not a simple event. So we just got some notation definitions here. P is probability, A, B, and C are specific events, so P of A denotes the probability of event A occurring. So you have relative frequency approximation. So you measure the number of times A occurs, and you measure the total number of times you repeated the process. So that would be the relative frequency. So, if you rolled the die 10 times and got 4 on the die 5 times, you'd say that there's a 50% chance that you roll a 4 with this die. You got 5 out of 10, which is 1/2. The classical event was the one we more commonly use. You count the number of ways the event can occur divided by the total number of events. So on a 6-sided die, the likelihood of getting a 4 isn't 50%, 1/2. It's 1 out of 6. But if you just counted the measurements, you could have gotten lucky if you're assuming that 4 is lucky. Just by chance, you could have rolled 4 more often than you should have. So normally we use the classical approach. So subjective probabilities, you're just estimating using knowledge of the relevant circumstances. You know how likely something should be. All right, and then we got up here another definition, law of large numbers. So it just says this procedure is repeated again and again. The relative frequency tends to approach the actual probability. So from the previous page there, that means the more often you conduct a test, the closer the relative frequency approximation gets to be the classical approach. So for small sample sets, it's not a very good approximation, but as you roll more and more times, you get a better and better estimation of the actual event. So example 2 here, a recent Harris Poll interactive survey of 1,010 adults showed that 202 of them smoke, found that probably that a randomly selected adult in the United States is a smoker. So this is relatively straightforward. We count up the number of smokers we have, which was 202. We divide it by the total number of people we surveyed, so 101. So probabilities can either be fractions or decimals. It doesn't actually matter. So if you want to leave it as a fraction, 202 out of 101 is 1/5. If you want to make it a decimal, 0.2 would be your probability. So example 3 down here, find the probability that the selected subject got a positive test result. So the first thing we need to do is figure out how many total people we tested. So that's 44 plus 6 plus 90 plus 860. 44 plus 6 plus 90 plus 860. So there were a total of 1,000 tests, and we want to know the likelihood that the subject got a positive test result. So positive test result is anyone in these two columns. It doesn't matter if they did or didn't actually use drugs, it's they tested positive. So that is 134. So that, if it reduces, is 67 out of 500, or as a decimal, 0.134 is your probability. Okay, so a couple more examples here. So example 4 says when 3 children are born, the sample of genders or sample space is all boys, 2 boys and a girl, but there's 1, 2, 3 ways that can happen. Oops, sorry, 2 boys, 2 boys, 2 boys. I did them out of order. 2 girls, 2 girls, 2 girls, or all girls. And if boys and girls are equally likely, then the 8 simple events, so 1, 2, 3, 4, 5, 6, 7, 8, are all equally likely. Assuming that boys and girls are equally likely, find the probability of getting 3 children, all of the same gender, when 3 children are born. So there's 8 possible ways that you can have 3 kids, and there are 2 of them give you all kids of the same gender, triple boys, triple girls. So that's 1 in 4, or 0.25 is the probability. All right, so example 5 here. Bills from 17 large cities were analyzed for the presence of cocaine. 23 of the bills were not tainted. 211 were tainted. With bills randomly selected, probably that it is tainted. So 211 were tainted, but the bottom number is how many total bills I have, so which is 234 bills. So if we take 211 divided by 234, we get 0.90, and we'll go another place, 2. It's almost 90% with the probability. All right, so example 6 here. If a year is selected at random, find the probability that Thanksgiving in the United States will be on A, a Wednesday, or B, a Thursday. So for A, there's a really quick trick. This is a trick question. Thanksgiving is never on a Wednesday. It is always on a Thursday. So probability of something never happening is 0. Always happening is a 1. So it's a little bit of a trick question. So down here, we've got complementary events. So the complement event A, denoted by A with a bar over the top, consists of all outcomes in which event A does not occur. So example 7, we randomly select an adult in the United States. Selecting a smoker is 0.2. Find the probability of randomly selecting an adult and getting someone who does not smoke. So the two probabilities have to add up to 1 because that's everyone. So if 20 or 0.2 is a probability of finding a smoker, 0.8 is a probability of finding a non-smoker. Okay, just a couple more definitions up here. An event is unlikely if its probability is very small, such as 0.05 or less. An event has an unusually low number of outcomes, or an unusually high if these not numbers far from what we typically expect. So unlikely and unusual don't necessarily have to mean the same thing. So example 8 here, when a fair coin is tossed 1,000 times, the result consists of exactly 500 heads. The probability of exactly 500 heads in 1,000 tosses is 0.0252. Is this result unlikely? So yes, because that's a very low percent. It is unlikely that happens. Now, is it unusually high, unusually low? Well, no, because you'd expect about half of them to be. So unlikely references the probability. Unusual references whether it's unexpected or not. So the second part down here, the result is 10 heads. Is this result unlikely? Yes, that result is also unlikely. This is also very, very far below what we would expect, so this is also unusually low. You would not expect to get only 10 heads if you flip the coin 1,000 times. Okay, so example 9. In the clinical experiment of the Salk vaccine for polio, 200,745 children were given placebo, 201,229 other children were treated with the vaccine. There are 115 cases of polio among the placebo group and 33 cases of polio in the treatment group. If we assume the vaccine has no effect, the probability of getting such test results is less than 0.001. What does that probability imply about the effectiveness of the vaccine? So if we're assuming that the vaccine has no effect, the probability is less than 0.1%, if we move the decimal right place. It's unlikely an event occurs if its probability is less than 0.05. So this occurring is unlikely, which means it is unlikely the vaccine has no effect. Oops. Because that's such a low probability. Okay, so here, some important principles. The probability of event is a fraction or decimal between 0 and 1. Inclusive, meaning that the probability can be 0, the probability can be 1. The probability of an impossible event is 0, so that was the Thanksgiving on a Wednesday. Probability of an event that is certain to occur is 1, so that's guaranteed to happen, so that's Thanksgiving on a Thursday. The probability of event A is P of A. Probability of event A does not occur is P bar, or A with the bar over the top. Okay, so now we've got odds. So we're going to talk about odds against, odds for, payoff odds, etc., things like that. So the actual odds against event occurring is the ratio of the event not occurring to the event actually occurring. Normally it's written as a ratio, so with a colon or A to B, where they're integers, and it's reduced as much as possible. So integers means you can't have a fraction inside your ratio or a decimal. Actual odds in favor is the reverse. You put the thing you want to occur on top. So if the odds against are A to B, odds in favor B to A. The payoff odds against an event occurring are the net profit relative to the bet amount. So the last example here, I believe, let's see, let's look ahead. Yeah, last example. If you bet $5 on the number 13 in roulette, your probability of winning is 1 in 38, and the payoff odds given by the casino, 35 to 1. Find the actual odds against an outcome of 13. So, to this, you actually need to know how many numbers are on a roulette wheel. So there are, did I miss a part? Oh, no, sorry, right there. 1 in 38. So there's 38 total numbers on the roulette wheel. So the odds against 13 are the likelihood you don't get the number you want. So that's 37 of the 38 numbers are the wrong number, and 1 is the one that you do want. So that's the odds against likelihood of not getting the thing you want compared to the thing you do want. So 37 to 1. How much profit would you make by betting on 13? So it's 35 to 1. So for every $1 you bet, you get $35 back in profit. So that would be 5 times 35, which according to the handy dandy calculator is $175 on your bet. The last one down here, if the casino is not operating for profit and the payoff odds were changed to match an actual odds against, how much would you win if the outcome was $13? So that means you'd be using these odds. You get paid $37 for every dollar you bet. So 5 times 37 is $185. But this is where the casinos make their money. The odds are 35 to 1, even though it's actually 37 to 1. So they're making their money on that $10 difference. So the casino always will come out ahead. The house always wins. And that is the end for this section.